Welcome to the Deep Dive. Today, we're taking a deep dive into software design with the book Dive into Design Patterns. It seems like you're all ready to level up your coding game.
That's right. We'll be exploring the fundamentals of object-oriented programming, or OOP for short, and how it helps us write elegant and reusable code.
I love that idea of reusable code. It's like having a superpower.
I like that.
Speaking of super, this excerpt we're looking at even has a dedication to the author's wife, Maria.
Yeah, the author, Alexander Shvets, says the book would have taken 30 years longer to write without her.
Wow. Sounds like she deserves a medal for patience.
Yeah, Phil.
Okay, enough about spouses. Let's talk code. The intro dives right into this OOP thing.
Right.
You mentioned it's key to good software design, but for those of us who aren't software engineers, can you break down why OOP is so important?
Sure. Imagine you're building a house. Would you rather have a pile of random bricks and boards,
Definitely not.
or a set of pre-designed walls, doors, and windows?
I'd take the pre-designed stuff any day.
Exactly. OPP is like having those pre-designed components, but for software. It gives us a structured way to think about and organize our code using objects.
Okay, so objects are like those pre-designed components. What exactly are they in the context of software?
Think of objects as bundles of data and actions.
Okay.
Like a cat object would have data like its name, color, breed,
Makes sense.
and actions like meow, sleep, or chase a laser pointer.
So it's not just describing what the cat is, it's also what the cat does.
Exactly. And here's where the cool part comes in. These objects are created from blueprints called classes.
Uh-huh.
A cat class would define the basic structure and behavior of all cats.
Ah, so that's where the object-oriented part comes in. We're not just writing lines of code, we're creating these objects that interact with each other.
Yeah,
It's like building a virtual world.
it really is. And to make things even more efficient, OP has this awesome thing called inheritance.
Okay.
So imagine a Siamese cat class.
Yes.
It doesn't need to define all the basic cat stuff again.
Yeah.
It can just inherit those traits from the general cat class.
Yeah.
It's all about saving time and avoiding redundant code.
Inheritance. So it's like a family tree for code. Makes total sense. But I have to ask, why go through all this trouble with OOP? Can't we just make the software work? Even if it's a bit messy behind the scenes.
Well, that's where it gets interesting. Good design isn't just about making things work. It's about making them adaptable for the future.
You mean like adding new features or fixing bugs?
Yeah, exactly. Things are always changing in tech.
Definitely.
And imagine if every time you needed to make a change, you had to rewrite huge chunks of code. It would be a nightmare.
Oh, yeah. That does not sound fun. So good design is about thinking ahead
Yeah,
and building things in a way that makes them easy to change.
precisely. It's like building a house with separate rooms. If you need to remodel the kitchen, you don't have to tear down the whole house.
Right.
You can just focus on that one room.
That's a great analogy. So OOP helps us create these separate rooms in our code.
Exactly. And that brings us to the concept of encapsulation. It's one of the core principles of OOP.
Okay.
And it's all about bundling the data and actions of an object together and then protecting them from outside interference. This makes our code more reliable and less prone to errors.
So encapsulation is like putting a protective shield around our code rooms so they don't accidentally mess with each other.
You got it. And there's another key principle called polymorphism.
Polymorphism.
It's a fancy word, but it basically means that objects can take on different forms or behaviors.
Okay.
Think of it like this. You can have a speak action for both a cat and a dog class,
Right.
but each animal will speak in its own way, a meow versus a bark.
Polymorphism. It's like giving our code superpowers.
Mm.
It can adapt and do different things depending on the context. But all this talk of good design has me curious. Are there like best practices? How do we know we're designing things the right way?
That's where design patterns come in.
Yeah.
They're like proven solutions to common design problems. Think of them as blueprints for building flexible and maintainable software.
So instead of reinventing the wheel every time, we can use these pre-made patterns to guide our design.
Exactly. The book excerpt focuses on the factory method pattern.
Okay.
It's a classic example of good design in action.
A factory for making code. I'm intrigued. What exactly does this factory produce?
Think of it as a factory for creating objects without specifying their concrete classes. It's a bit abstract, so let's use a real-world example. Imagine you're building a logistics app
Okay.
that needs to handle different types of transportation, like trucks and ships.
Okay, so we have trucks delivering on land and ships transporting things overseas.
Right.
I can see how that could get complex.
And without good design, adding a new transport type, like airplanes, could mean rewriting a ton of code.
Oh, yeah. That would be a logistical nightmare.
It would, so the factory method helps us avoid those nightmares.
It does.
It lets us add new products, like those airplanes, without modifying the existing code base. It's all about making our code more flexible and adaptable.
I love that. But I have to admit, I'm a bit lost on how this actually works. Is it really like a factory?
It is. Think of it this way. We have this factory that produces objects, like our trucks or ships.
Okay. So far, so good.
But instead of having a whole separate factory for each vehicle type, which would get really messy fast as we add more and more options.
Right, like if we add airplanes, drones, maybe even spaceships someday.
Exactly. So we create a more general transport factory that knows how to make any kind of transport vehicle.
So it's like a master factory that oversees all the other factories.
That's a great way to think about it.
Yeah.
This master factory is actually an interface, which is like a contract that says, hey, here are the methods that our factory must have.
Methods. Remind me what those are again.
Oh, right. Think of them as the actions that our objects can perform.
Okay.
In this case, our transport factory interface would have a method called create transport.
Okay, so any concrete factory, like the one for trucks or ships, has to implement this create transport method.
Precisely. And that's the magic of the factory method pattern.
Yeah.
The client code, the part of our app that needs to use these transport vehicles.
Right, like the part that figures out the best way to ship a package.
Exactly. That client code doesn't need to know anything about the specifics of how each vehicle is created.
Interesting.
It just says, hey, transport factory, create transport, and specifies the type that it needs.
So it's like saying, hey, factory, I need a truck, or hey, factory, I need a ship, and the factory takes care of the rest.
You got it. The factory looks at the type, figures out which concrete factory it needs to use,
Okay.
and then boom, it returns us the right object.
Oh, I see. This is starting to click. It's like having a universal remote control for creating objects. We don't need to know which buttons to press for each specific device. The remote just handles it for us.
Exactly. And that's why the factory method is so powerful. It decouples the creation of objects from their usage, making our code more flexible and maintainable.
Decoupling sounds like we're breaking down complex tasks into smaller, more manageable chunks.
Yeah. And that's a great way to think about it. This modularity is key to building really robust software that can grow and change over time.
So we're not just writing code, we're creating systems that are well organized, adaptable, and easy to understand.
Precisely. And the factory method is just one of many design patterns that can help us achieve this.
I'm telling you, this is blowing my mind. It's like we've gone from building with Lego bricks to designing complex architectural masterpieces.
I love that. And as we delve deeper into design patterns, we'll discover even more elegant solutions to common software design challenges.
I'm ready for the next challenge. But before we move on, can we recap the key benefits of the factory method? Just want to make sure I've got this.
Of course. So the factory method, it promotes flexibility by letting us add new product types, like our airplane, without modifying existing code.
It enhances code reuse by centralizing object creation logic.
Right.
And it improves maintainability by keeping our code base clean and organized.
Okay, so flexibility, code reuse, and maintainability. Those are the superpowers of the factory method.
Exactly. And these superpowers are essential for building software that can adapt to changing requirements and stand the test of time.
Incredible. I'm starting to see the world of software design in a whole new light.
And we've only just scratched the surface. There's so much more to explore, but for now,
Yeah.
let's take a moment to appreciate the elegance and power of the factory method.
Absolutely. It's really a testament to the ingenuity of software engineers and their ability to create solutions that are both practical and beautiful.
Indeed. And as we continue our deep dive, we'll encounter even more examples of this.
I'm excited to see what other design gems are waiting for us. But I think we could both use a little break before we venture further. All right, I'm back, ready for more design pattern goodness.
Excellent. You know, it's like we've unlocked a secret level in software design. Right. And it's pretty amazing how these patterns can make really complex things, well, so much simpler. I mean, we've only scratched the surface here, but I already feel like I've got all these new tools.
You do. And the more patterns you learn, the more you start to see how they're all connected.
Yeah.
It's not just about individual solutions, but a whole design philosophy.
That makes sense, like learning a new language, right?
Exactly. Once you know the grammar, you can express yourself in more creative and nuanced ways.
And speaking of expressing ourselves, the excerpt we're looking at also mentions code reuse,
Right.
which, we touched on earlier. It says good design makes it easier to reuse code,
It does.
which saves a ton of time and effort. But how does that actually work in practice?
Well, one pattern that comes to mind is the facade pattern. It's all about simplifying complex systems and making them easier to use and reuse.
Okay, I'm listening. Facade sounds intriguing.
Okay. Think of it this way. You have a complex system with lots of moving parts. Maybe like a home entertainment system, with a TV, a Blu-ray player, a sound system, a streaming device.
Right, and each one has its own remote, its own settings, its own quirks. Ugh, it can be so overwhelming.
Exactly. So now imagine if you had one universal remote that simplified all those controls. That's what the facade pattern does for software.
It's interesting.
It creates a simplified interface to a complex subsystem, and it hides all those messy details behind a clean, well-defined API.
Wait, API, what's that?
Oh yeah, it stands for Application Programming Interface.
Okay.
And it's essentially a set of rules and specifications that define how different software components can interact with each other. Think of it like a menu at a restaurant.
Okay.
You don't need to know how they're making the food in the back,
Right.
You just need to know what dishes are available and how to order them.
Right. Okay, that makes sense. So the facade pattern is like creating this menu for a complex subsystem, making it easier to use.
Exactly. Instead of having to understand all those intricacies of the subsystem, you just use the facade's simplified interface to interact with it.
So it's like having a personal assistant for our code. We just tell the facade what we need, and it takes care of all the details.
That's a great way to put it. And this simplification, it makes it much easier to reuse code. Instead of having to copy and paste large chunks of code, you can just use the facade to access that functionality that you need.
I'm really loving how this is all about making our code more elegant and efficient. But wouldn't hiding all that complexity make it harder to understand what's going on under the hood? I mean, what if we need to troubleshoot something?
That's a valid concern. But the facade pattern doesn't eliminate complexity.
It doesn't.
No, it manages it.
Okay.
It's like having a well-organized toolbox.
Right.
All the tools are still there, but they're neatly arranged and labeled so you can easily find what you need.
Okay, so it's not about pretending the complexity doesn't exist. It's about making it more accessible and manageable.
Exactly. The facade pattern strikes a balance between simplicity and flexibility. It gives you that simplified interface for everyday use, but you can still access the underlying subsystem if you need to.
Okay. I'm starting to see how powerful this can be. Can you give me a concrete example, like how it might be used in a real-world application?
Sure. Imagine you're building a music streaming application.
Okay.
And it involves this complex subsystem for handling audio playback, buffering, all the streaming protocols, and so on.
Right. There's a lot going on behind the scenes to make that smooth listening experience happen.
A lot. Now, imagine trying to access all that functionality directly from different parts of your application.
Yeah.
It would be a tangled mess. So instead, you can create an audio player facade that gives you this nice, simple interface for playing, pausing, stopping, and controlling the volume of the music.
So the audio player facade is like the control panel on a stereo system. It gives us those essential buttons we need without having to see all the wiring underneath.
Perfect analogy. And by using this facade, other parts of your application don't need to worry about all those low-level details of audio playback.
Right.
They can just interact with the audio player and trust that it'll handle everything correctly.
This is brilliant. It's like we've created a specialized team of code experts to handle those complex tasks so the rest of our code can focus on the big picture.
And that's exactly what good design is all about.
It is.
Breaking down these complex problems into smaller, more manageable pieces and creating systems that are both powerful and easy to work with.
This deep dive has been incredible. I feel like I've gained a whole new understanding of what it means to write elegant and maintainable code.
And we've only just scratched the surface. There's a whole universe of design patterns out there, each one offering unique solutions to common challenges.
I can't wait to explore more of them. But for now, I want to thank you for sharing your expertise and for opening my eyes to the beauty of well-designed software.
It's been my pleasure. And remember, the journey of software design is an ongoing one. There's always something new to learn. And the more we explore, the more we discover the art and elegance behind the technology we use every day.
And to you, our listener, we encourage you to keep diving deeper into the world of software design. You might be surprised at what you find.
Until next time, happy coding.